the process by which hydrogen atoms join together to form helium inside the sun. Nuclear fusion in the sun is when hydrogen atoms combine to create helium, releasing energy that powers the sun.
Imagine trying to squeeze two very stubborn magnets together with the same poles facing each other as they keep pushing away from one another. This is similar to what happens in the sun, where hydrogen atoms resist each other due to their positive charges. Yet, under immense pressure and heat, they are forced to combine to form helium. Just as you need to apply a significant force to overcome the repulsion between the magnets, the sun's core provides the intense pressure and temperature needed to overcome the repulsive forces between hydrogen atoms, allowing nuclear fusion to occur.
The distance light travels in a year, 9.5 trillion kilometers, light year. A light year is a unit of distance that measures how far light travels in 1 year in space.
Imagine you're planning a long road trip across the country to visit family and you're trying to grasp just how far you need to travel. Just like planning out that enormous distance can seem daunting, understanding the concept of a light year is about comprehending a vast space that can be challenging to visualize. In both cases, you're dealing with large-scale journeys. Your road trip covers thousands of kilometers, whereas a light year covers the distance light travels in a year, 9.5 trillion kilometers. So just like your car journey is broken down into manageable parts like hours and stops, think of the light year as breaking down the immense stretches of space into something we can wrap our minds around by considering how far light, the fastest thing in the universe, travels in the span of a year.
The apparent change in position of an object when viewed from different places. Parallax. Parallax is the way an object's position seems to shift when you look at it from different angles or locations.
Imagine trying to find the perfect spot to hang a picture on a wall, and every time you move to a different part of the room, the picture seems to shift its position slightly. This is similar to the scientific concept of parallax, where the position of an object appears to change when viewed from different locations. Just as the picture seems to move because your angle of view changes, celestial objects like stars or planets appear to shift against the distant background stars as the Earth moves to different points in its orbit, allowing astronomers to measure their distances.
A huge cloud of gas and dust in space where new stars form. Nebula. A nebula is a massive space cloud where stars are born.
Imagine trying to clean up a cluttered room where things are scattered everywhere, but eventually you start to see the potential for something new and organized. Just like tidying up transforms a chaotic space into something functional, a nebula is a vast chaotic cloud of gas and dust that can eventually form new stars. The scattered items in the room are like the particles in the nebula, which, when they come together in just the right way, create a new structure, much like the formation of stars from the nebula's material.
The distinct diagonal band on an HR diagram that includes 90 of all stars' main sequence. Main sequence stars are those that are in the stable phase of their life cycle, fusing hydrogen into helium in their cores.
Imagine trying to organize a diverse group of people by age and height, noticing that most fit into a predictable pattern where older people are generally taller. This is similar to how stars in the universe are organized by their brightness and temperature, forming a predictable pattern known as the main sequence on the HR diagram. Just as most people fall along a diagonal trend from younger and shorter to older and taller, about 90% of stars fall along a diagonal band on the HR diagram, from hot and bright to cool and dim, illustrating a natural order in both scenarios.
A dense core composed mainly of neutrons, left behind after a supernova explosion. Neutron star. A neutron star is a supercompact object formed when a massive star's core collapses under gravity after a supernova, squeezing its mass into a small, incredibly dense ball mostly made of neutrons.
Imagine trying to fit all your clothes into an overstuffed suitcase after a long vacation. Just like how you compress every piece of clothing tightly together to make it fit, a neutron star is the incredibly dense core that remains after a massive star explodes in a supernova, squeezing neutrons closely together. In both cases, you have a situation where a large volume is condensed into a much smaller space. Your suitcase is the neutron star, and the densely packed clothes are akin to the neutrons, both representing how much can be crammed into a limited space.
A region in space with gravity so strong that no matter or light can escape it. A black hole is an area in space where gravity pulls so much that even light cannot get out.
Imagine you're trying to leave a crowded party where the music is so loud and the crowd so dense that you can barely move or hear yourself think. This situation is similar to a black hole, where gravity is so intense that not even light can escape its pull. Just as the noise and people at the party trap you in place, the immense gravitational force of a black hole traps everything close by, making it impossible for light or matter to break free.
The very bright center of a distant galaxy, quasar. A quasar is an extremely bright and energetic object powered by a supermassive black hole at the center of a galaxy.
Imagine trying to find your friend at a crowded concert when they're standing right under a bright spotlight. Just like that spotlight makes your friend easy to spot in a sea of people, a quasar is the incredibly luminous center of a distant galaxy, making it stand out in the vastness of space. The spotlight is to your friend what the quasar is to the galaxy. Both make their respective subjects visible and prominent against a crowded and chaotic background.
States that the universe began with a huge explosion 13.8 billion years ago. Big Bang Theory. The Big Bang Theory explains how the universe started from an extremely hot and dense point and has been expanding ever since.
Imagine you're in a crowded party where there's barely any space to move, and suddenly someone drops a tray of drinks, causing everyone to scatter in all directions. This initial explosion of movement from a single point mirrors how the universe began with the Big Bang, where everything expanded rapidly from a singular, dense state. Just like the partygoers spreading out from the center, the universe's galaxies, stars, and planets have been moving away from the original explosion point, filling up the vast cosmic space over 13.8 billion years.
The brightness of a star as seen from Earth apparent magnitude. Apparent magnitude is a measure of how bright a star appears to us in the sky from Earth.
Imagine trying to choose the loudest person at a crowded party, where some people are shouting right next to you and others are speaking quietly from across the room. Just like the apparent loudness of someone's voice depends on their distance from you and how loudly they're actually speaking, the apparent magnitude of a star is how bright it seems from Earth, influenced by both its intrinsic brightness and how far away it is. In this analogy, the people at the party are the stars, their voices are their intrinsic brightness, and your perception of their loudness is the apparent magnitude, which helps you decide who seems loudest based on proximity and volume.
The brightness of a star as seen from a distance of 10 parsecs. Absolute magnitude. Absolute magnitude is a measure of how bright a star would appear if it were 10 parsecs away from Earth.
Imagine you're trying to compare the loudness of songs played at different distances in a crowded street. Just like how you might struggle to gauge which song is truly louder unless you bring all the speakers to the same spot and listen from the same distance, astronomers face a similar challenge with stars. Absolute magnitude is like this standardized listening spot. It's the brightness of a star as if it were observed from a uniform distance of 10 parsecs, allowing astronomers to fairly compare the intrinsic brightness of stars without the varying effects of distance.
The bright explosion of a dying supergiant star. Supernova. A supernova is a powerful burst of light and energy that happens when a massive star explodes at the end of its life.
Imagine you're trying to hold onto a large stack of boxes while climbing a staircase, but eventually you lose your balance, and the boxes come crashing down in a spectacular mess. This chaotic scene is similar to a supernova, where a massive supergiant star can no longer support the immense pressure of its own gravity and collapses. Just as the stack of boxes becomes unstable and falls apart, the star's core succumbs to gravitational forces, leading to a dramatic explosion that we see as a bright supernova in the sky.
The hot, dense core of a star left behind when its outer layers have escaped into space. White dwarf. A white dwarf is the remains of a small or medium-sized star after it has exhausted its nuclear fuel and shed its outer layers.
Imagine you're cleaning out a closet, deciding to get rid of old clothes you no longer wear. Once you've discarded the excess, you're left with a neat, compact collection of just your essential items. Similarly, when a star sheds its outer layers and loses the material it no longer needs, it leaves behind a white dwarf, a dense core of what once was. Just as your streamlined closet represents the core essentials after a big cleanout, a white dwarf is the remaining core of a star, stripped down to its fundamental, dense state after shedding its outer layers into space.
A massive system of stars, gases, and dust held together by gravity. A galaxy is a huge collection of stars and other matter bound together by gravity.
Imagine trying to keep a group of friends together at a crowded concert where everyone is being pushed and pulled by the crowd. Just like how your friends stick close to you to avoid getting lost, a galaxy is a massive system of stars, gases, and dust, all held together by gravity, preventing them from drifting apart in the vastness of space. In this analogy, gravity acts like the bond of friendship, keeping everything, stars, gas, and dust, clustered together despite the chaotic movements around them, much like how your group stays unified amidst the concert's bustling crowd.